So lesson number 2 in Unit 4, we're still working with slope. This is using slope finding slope using similar triangles. So on your anchor chart for your triangles, I'd like you to write these measurements for the two triangles. On this first triangle, we have 3, 6, and 9. On the second triangle, we have 9, 18, and 27. Go ahead and take the time to write that on your anchor chart. Okay. So similar triangles have the same ratio between the sides. I'd like you to write that up here. And we find this ratio between sides by comparing our new and our old shapes. So we're going to use a comparison of new over old. Okay, so we're going to pick a triangle to be our new triangle. I'm going to pick the smaller one as my new triangle. New. And I'm just going to mark it with an N. And my old triangle, I'm going to mark with an O. Okay. And so we're going to set this up in a comparison ratio. And I'm going to take a measurement from a new side and compare it to the same measurement or the same measurement on the old side. So in this case, I'm going to use this long side. It's called the hypotenuse. We'll use this more in a future unit. I will put that at the top of my ratio. And you need to use the same side of that shape. So I would use this long side here, the hypotenuse of my old triangle. So I'm going to write 9 over 27. And now I need to compare it to another set of sides to make sure that we're going to have the same ratio. So I'm going to choose this shortest side here, the vertical line on my new triangle. And compare it to the vertical line on my old triangle. Okay, and we need to set these equal to each other. So what this means is if I reduce this fraction as far as it will go, and I reduce this fraction as far as it will go, I should end up with the same number because the ratio between the sides should be the same. So (9 over 27) reduces down to 1/3. and 3/9 reduces to 1/3. So I just took these two fractions and reduced them over here. I didn't change anything. I just changed the way I was looking at them. And because they both come out to the same ratio inside, 1/3 and 1/3, these triangles are similar triangles. Because when I compared this side and this side, my new triangle, the hypotenuse of my new triangle, is 1/3 the size of the hypotenuse of my old triangle. I set it equal to here, the A leg of my new triangle compared to the A leg of my old triangle. My new triangle on this length is 1/3 the size of my old triangle. Because this side here and this side here are the same reduction in size, they're similar triangles. They have the same ratio. If you were to compare the hypotenuse here to the leg here, it's also 1/3. If you compare the hypotenuse and the leg here, you have a 1/3 ratio. So because all of the ratios come out to the same amount, 1/3, you have similar triangles. So in the past, you've used triangles to find the slope of a line. You've called this your rise over your run. And if you recall from the last anchor chart we covered, we're not calling it rise over run. This year, and from this point forward, these are going to be referred to as your change in y over your change in x. You used to call it your rise. Okay? And then any movement across the top, any movement vertically, up or down, is your change in y. Any movement horizontally, left or right, from this point forward, is referred to as your change in x. You used to call it the run. In younger grades, we called it rise over run because it was an easier method for you to remember what was happening. We now call it change in y over change in x because you're able to understand that when you're talking about vertical movement, you're moving along the y-axis, and when you're talking about horizontal movement, you're moving along the x-axis. So we are going to find 2 points on this line. When you're looking for points along a line and they have not been labeled for you, what you're looking for is where a Y line and an X line intersect with the drawn line. So one of those points we have here. This Y line here. You don't need to draw these intersections. I'm just going to draw them for you. This Y line here intersects with the X line there, and also intersects with the drawn slope, giving us 1 point. Here, we have this Y line intersects with this X line here, giving us another point on our slope. What you will draw is the triangle made by these two. And you can see that here in my tracing of the lines, I have the leg of a triangle here and the leg of a triangle there. You'll draw yours directly on the X and Y lines. And so we, in the past, using the change in Y over change in X, we count how many movements. So we have one vertical movement, so one change in Y value. Again, delta means change in, it's a Greek symbol. Our change in Y is one value. We moved upwards, which gives us a positive value. If we were to move down to get to the point, it would be negative. And then we're going to count how many horizontal movements we have, or our change in X. We have 1, 2 horizontal movements. We had one vertical, 1, 2 horizontal movements. So our change in X is a change of 2. Okay. So when we put that together, change in Y over change in X gives us our slope. Our slope here is 1 over 2. And the slope is written as 1 over 2, not 1/2. Okay, so I'd like to point out that you have multiple triangles along this line. We also have another point where a Y and an X line intersect with this drawn slope, giving us a second triangle here. And along this line up here. So let's count the movements for this larger triangle. We have 1, 2 vertical movements. And I'm going to call this the larger triangle. This is our small triangle. And I'll have my large triangle over here. Okay. So for this triangle here, I'll write in the same color that I drew the lines in so it can coordinate for you. My change in Y, or my vertical change, is 1, 2 movements. Okay? And we're going to place that over my change in X, or your horizontal movements. Again, I'm still moving in a vertical direction. 1, 2, 3, 4 movements. My horizontal movements is 4 movements. So in this case, my change in Y over change in X is 2 over 4. With your experience with fractions from the previous years, you know that you can reduce 2 over 4 by a value of 2. So this reduces down to a slope of 1 over 2. So your slope still equals 1 over 2. So no matter what points you pick on a given line, you're going to end up with the same slope. Okay? And that's because of the rule of similar triangles. You're going to write this here. And the rule for similar triangles is that 2 triangles on the same line have the same slope. They always do, they always will. 2 triangles on the same line have the same slope. Repeat that 3 times. 2 triangles that fall in the same line have the same slope. It's supposed to be an N, sorry. Two triangles that fall in the same line have the same slope. Just going to fill this in a little darker while you write. So if you see a question that asks about a statement for this triangle A and this triangle B on this same line, you can say that triangle A and triangle B have the same slope because they are similar triangles. Okay? Because these 2 triangles fall on this same line on the graph, they have the same slope. It will always be true. If 2 triangles fall on the same line, they have the same slope. I've said it 6,000 times because it's really important for you to remember the rule of similar triangles and slope. Here I have a problem for you to solve. It says, I will write the proportion that shows the equality of the slopes of AC and CE. So that means you're going to do this on this triangle. You will compare this line here to this same side here, and you will compare this height here to this height here. Set your proportion up like this.